Hi class, so this video is a second video to my last video. So I realized after I published the video that I made a simple error here when I was calculating the mean of our data. So what I realized that I did is when I calculated the mean, I forgot to include the value 16, right? So if you notice here, I went from 9 to 15 when I skipped over 16 from our data, which was the fifth data point. So our mean is off, which also means that our standard deviation would be off, right? Because we calculated standard deviation by taking each x value, subtracting the mean, right? And then we squared those values, added all those up, and then we divided by n minus 1, and then took the square root of that answer, right, to get standard deviation. So that's going to throw everything off, right? But I'm not going to redo this video because I think, although I made an error there, I think you've gotten a basic understanding for what these symbols mean and how you would go about calculating this by hand. Which we won't have to do in this class, but I think there's value in knowing how to calculate by hand, so that way you can work through things, right? All right, so I'll leave that up to you to correct that arithmetic error. But another thing that I did want to show you is how to do some of this in Excel, right? So I posted this Excel file named ACT in Excel. So I have a bunch of ACT scores here. So if I highlight all these, notice at the bottom it'll tell me the count. So we have 120 ACT scores, right, listed here. So first thing that I would do when working with this is we're going to reference where this range where all of our numbers are often. So I would do an absolute cell reference by naming this range, right? So you highlight all the cells as I did, and then we can click here in the name box, and I'm just going to name it data, right, and hit enter, right? So now that's named, right? So then in a previous video I've shown you how to create a histogram in Excel, right? So we get practice with that again. So you're going to click in here and use the count if function, right? So let me zoom in here a little bit. Here. Need to erase this so I can zoom in a little bit for you. Right? So I would hit equals the count if function, and then my range I call data, right? So I have that, and then my criteria is what I have here on the left, right? So I can close that parenthesis, hit enter, and then I can just double click on the fill down and it will take that all the way down for me, right? So then now, remember to get frequency for the first bin, I just set equal to whatever this count is over here, right? But then I explained previously that to get this frequency, right, we need to take this value minus this value, right? So that way we're only capturing the values from 3 to 5. And then now I can go ahead and fill this down, and that should be correct, right? And we can double check if I highlight this. Again, I can look down here for the sum. The sum is 120, which should be right, because we had 120 data points, right? So then next we want to create the histogram, right, part B. So if I highlight these two columns, then I can go to insert, and we want to go to bar chart, right? Remember, and I'll go ahead and drag this down where I'd asked you to place this, right, if this were like an assignment. And then remember, it's important to give it a title, right? So this would be histogram of ACT scores for you could be more specific, right? So maybe it was for Grant, or maybe Harding High School, right? So we don't know what school it's from, but if you knew what school it's from, it's important to be as specific as you can in the title. So that way if someone gets your graph, like maybe outside your school district or whatnot, they know what the data's for, right? But remember the histogram, a big difference between a histogram and bar chart is that our bars are touching. So we need to change the gap width. Again, I told you guys previously, I like to do about 5%. I just think that looks the best. So then here's our histogram, right? Alright, so then so we have that. So part B says, what type of histogram do you have? What do you think? Right, so again, we're looking at this overall shape and trying to see what the overall data shape looks like. I would have to argue that this looks symmetric, right? So right, so probably what I would type something in here is I would say like we have a symmetric distribution. So after looking at the histogram, the overall shape is symmetrical with the tallest bars in the center. We have a bell shape, right? Oops. And I can go in here and click Format Cells. And what I'm going to tell, so I'll go to Alignment, and then I'm going to tell Excel to wrap text. So what that'll do is it tells Excel it's okay to go to the next line, right? So that way it can all fit in that box, all the text, right? So remember when we're looking at distributions, I had a sheet up that described different distributions like right skewed, left skewed, and so forth, right? So you just want to have that as a reference when you're looking at distribution, right? So then to calculate the 8 basic statistics, right? I think I showed you how to do this last time also, right? So just as a refresher, right, I can go to mean and then type in data, right? And that'll calculate that for me. Whoops, excuse me. It is mean, but the Excel function is average, right? So then for median, it's called median of the data. Mode, remember it's MODE, and then data, right? Hit enter. Standard deviation equals STDEV. Remember we want the one, just the basic one, and then type in data. The min, right, is the min function, MIN, and we want to take this of the data. To find the maximum, we take the max function of the data, right, and have that. And then remember the range is the max minus the min, right? In our count, we can use the count function of data, right? So count function, the count function will only count numerical values, right? But something something that you want to know, if I highlight cells with words here at the bottom, it will count those, right? So that tells you the number of selected cells. But if I come over here and use count and select that same range, it gives me 0 back, right? So the count function only counts numerical values, but if you highlight and look at the bottom of Excel, it does count all the Excels with anything in them, right? So you just want to note that difference, right? Because sometimes I'll use that at the bottom. So like if I highlight all the data cells that we call data at the bottom, right, we can use this for the average, the count, and the sum, right? So you might want to use that from time to time, but just keep in mind if you select, like so for example, if I selected score in my range, then that count is not going to be accurate, right? Right, so then part D, right, we're looking at the standard deviation. So it says, what does the standard deviation tell us about our data? Right? So the standard deviation tells us that the average distance from the mean for our data values is 4.472 units, right? So again, I'm going to format cells, I'm going to wrap text, right, just to make this look neat, right? So we get to say something to that effect, right? So it's just to emphasize, do you know what standard deviation means, right? You can find the number, but what does it mean to you? Right? And then, so I already did a video on box plots and 5-number summary, but I wanted to show you how to find the 5-number summary in Excel, right? So we can hit equals min. We can use the min function for the minimum, right? So that's still the same. The median, right, would still be the median function of the data. The max would still be the max function of the data, right? So these 3 boxes are really part of the 8-number summary, right? But what's different is finding the first quartile or the third quartile, right? So to find that, you hit equals, and then you hit quartile. And again, let's use the one that is just the basic one, right? So click on that, and then we can type in data, and then you're going to hit comma, and notice Excel has a pop-down menu. So this is where we're going to tell Excel what quartile are we trying to find, right? So 0 is the min, so you could calculate the minimum that way if you wanted. Here's the quartile, first quartile, median, and so forth, right? So it tells you what value to put in here to get that. So we want the first quartile, so I put 1 and hit enter, right? So then to find the third quartile, we do something similar, right? Use the quartile function. We want to tell Excel, do this for this data, and then use 3 to get quartile 3, right? And hit enter, and there's our 5-number summary in Excel, right? And making a box plot in Excel is not very easy. It's actually a lot of steps, kind of hard. So if I were in practice, I would not use Excel to calculate that, right? So if I was to make a box plot, I would use R, right? So I mentioned earlier that I might bring up R from time to time in order to just show you some practicalities like of a statistical software. I think it's worthwhile for you just to see what one looks like, right? So all I did is I just copied and pasted all the scores and pasted in a new Excel file because Excel or R has to have a special type of Excel file, right? So I'm not going to explain what I'm doing in Excel. I just want to, or I'm not going to explain fully what I'm doing inside of R. Again, I don't expect you to use R. I just want you to see what it looks like, right? So I'm just going to call this ACT. Well, I already have a file called that. .csv. I'll just do that. Yes. Yes. Alright, so let me open up R. Let me make the text bigger for you. Alright. So let me get R set up. So basically what I'm doing here is just telling R where I'm working at, right? Where's my working directory is what this is called, right? So I'm telling R my files on my desktop, right? So now I need to tell R what my file name is. So I'm just going to call my data and tell it to grab a CSV file. I call it ACT, right? Then I got to attach my data. I got to tell R, please use this. And then if I go to names of data, it'll tell me my variables. All right. So then now I can do summary of my variable, and this pops up the 5-number summary plus the mean, right? So that's kind of convenient to have, right? So I have my minimum, my first quartile, and so forth of those data values, right? I'm curious to see how this compares to Excel's calculations. Oops. So let me right. Yeah, so right on, right? It looks like R rounds to the nearest hundredth, right? So that's the only real difference. Right? And I could also find the oops, typing in the wrong box here, right? So I want to type in R. So I could also find the standard deviation of score, and we get the same value, right? So R in Excel are in agreement, which is good, right? So I could also find the count in R, which they both agree, right? So I checked everything in R, right? So now what I want to grab is make a box plot. Right. So here's the box plot for R, right? So I mean that's how easy it is to make it. I can just right click on it and I can copy the file and I can paste that like into Word or whatnot, right? And there's also ways I can add titles and so forth to this. So I think it's a much easier way to make a box plot than in Excel. Right? And I could also, oops, let me bring R back up. So I could also make a histogram really quick also. And it should be probably right here. Yep. Right, so there's a histogram. So you can see that that it appears to look symmetric, right? And there are some hard statistical tests that we can do to see if something's normally distributed, but I won't get into that with you. All right, so that's it for this video. I'll see you guys next time.